Hello students, welcome back to chemistry class. Today, let us continue the lesson carbon and its compounds. Let us recall what we have learned in the previous class. We have learned the properties of ethanoic acid and its reactions. In reactions, we have learned esterification, reaction with base and reaction with carbonates and hydrogen carbonates. What is esterification reaction? The formation of an ester when ethanoic acid reacts with an alcohol. The reverse reaction of this is called saponification because when ester reacts with an alkali like sodium hydroxide, we are getting sodium salt of the acid, ethanoic acid and ethanol. As the sodium salt of these carboxylic acids are called soap, this reaction is used in the preparation of soap, so this is called saponification. When ethanoic acid reacts with a base like sodium hydroxide, we are getting sodium salt of ethanoic acid or sodium, that is called sodium ethanoate or sodium acetate. When ethanoic acid reacts with carbonates or hydrogen carbonates, we are getting sodium salt of ethanoic acid, carbon dioxide and water. Today we are going to learn soaps and detergents. Let us see the cleansing action of soap. So we should know the nature of dirt and soap. Dirt is oily in nature. Most dirt is oily in nature and oil does not dissolve in water. So only with water the dirt will not be cleaned. So we are using the soaps or detergents. The soap molecules are sodium or potassium salts of long chain carboxylic acids. It has the formula R-COONa or R-COOK. You know the carboxylic acid formula is RCOOH. When the H is replaced by Na or K, we are getting R-COONa or R-COOK. These salts, the sodium salt or potassium salt of this carboxylic acid, that is called the soap. This is the structure of soap molecule. So here R is the alkyl group. You know already what are the alkyl group examples? Methyl group, ethyl, propyl, etc. But in the case of soap molecule, this R is a long chain alkyl group. So here is a soap molecule. You can see this is the R, alkyl group and RCOONa. Now this RCOONa, this is polar in nature. What is meant by polarity? Charge separation. You can see here the charge separation COO minus and Na plus. But this part is the hydrocarbon part is non-polar. There is no charge separation here. So a soap molecule is having two ends. One end is polar, the other end is non-polar. This water also polar in nature. It is having charge separation H plus and OH minus ions. So always polar substances will dissolve in polar solvents and non-polar substances will dissolve in non-polar solvents. So this part is polar in nature, so it is water loving or we can say hydrophilic. It is soluble in water. This is a non-polar part that is repelling away from water or we can say hydrophobic. Phobia means fear. Hydrophobic means repel away from water, but it dissolves in oil or grease. This is another representation. So here this is the hydrocarbon part similar to this and this is the carboxylic acid part, sodium salt. That means this is the ionic part or polar part which is hydrophilic, which is soluble in water. This is a long non-polar end or hydrophobic which is soluble in oil. So we have seen now soap molecules having two ends which have different properties. One is a hydrophilic or ionic end, that is, it interacts with water, while the other end is hydrophobic, that is a carbon chain, that is non-polar, that is, it interacts with the oil. So here this is the hydrophilic end or which dissolves in water, and this is a hydrophobic end or non-polar end which dissolves in grease or oil. So the soap molecules thus form the structures called micelles. Let us see how the micelle formation takes place. Where one end of the molecule is towards the oil droplet. Which end is towards the oil droplet? The hydrophobic hydrocarbon part. And the other end is facing outside. Which end? The ionic end or the hydrophilic part is facing outside towards the water. This forms an emulsion in water. What is meant by emulsion? A fine dispersion of one liquid in another in which it is not soluble or miscible. You know, water and oil are immiscible liquids. So here is a fine distribution, fine dispersion of this oil in the oil or dirt in the water. It forms an emulsion. The soap micelles thus helps in dissolving the dirt in water, and we can wash our clothes clean. So when the soap at the surface of water, what is happening? The hydrophobic tail of soap will not be soluble in water, we have seen now. So this hydrophobic part will be protruding out of water, and the hydrophilic end or ionic end is in the water. So when soap is at the surface of water, the hydrophobic tail of soap will not be soluble in water, and the soap will align along the surface of water with the ionic end in water. You can see here the ionic end in water and the hydrocarbon tail protruding out of water. When it is inside the water, what happens? These molecules, the micelle formation takes place here. These molecules have a unique orientation that keeps the hydrocarbon portion out of the water. You can see the hydrocarbon or hydrophobic part, water repelling part move away from the water. This is achieved by forming clusters of molecules in which the hydrophobic tails are in the interior of the cluster and the ionic ends are on the surface of the cluster. You can see here cluster of molecules, soap molecule. So many soap molecules form a cluster. The hydrophobic part are the interior of the cluster, and these are the hydrophobic part, hydrocarbon chain or water repelling part, and the hydrophilic part are the surface of the cluster. This is the formation of the micelle. And soap in the form of micelle is able to clean, since the oily dirt will be collected in the center of the micelle. So here you can see that hydrocarbon part is hydrophilic end is away from the dirt, and hydrophobic end is soluble in grease or dirt. Hydrophilic end is soluble in the water. So the hydrophobic end is soluble in the grease or oil. So dirt is oil in nature, already we have seen. So thus a micelle formation takes place. So you can see here, this is a cloth or fabric in the dirt. So soap molecule, when you are in the water, when we are mixing the soap, in that cloth are soaked, what will happen? This soap molecule align in such a way that this is a hydrophilic end and this is a hydrophobic end. So this hydrophobic end is attracted towards the dirt. It will form a micelle. So these so many micelles are formed in this. So the micelles stay in solution as a colloid and will not come together to precipitate because of ion-ion repulsion. You know, this micelle, the surface of the micelle is ionic in nature. That means it is having charge. So each surface of each micelle is having similar charges. They are repelling away from each other. So they will not come together to precipitate. So here, this what we explained here, everything is shown here. soap molecules having hydrophilic end and hydrophobic end. The hydrocarbon part, this is the ionic part or polar part, and this is a dirt, oily grease or dirt. So when this hydrophilic end will be attracted towards the water and hydrophobic end will be attracting towards the oil, and micelle formation takes place here. So oil will be at the center of this micelle, or the dirt will be, oil or dirt will be at the center of the micelle. So thus the dirt suspended in the micelles is also easily rinsed away. So when you are rinsing the cloth in water, these micelles will be removed from the cloth and cloth will be clean. This all have explained in this video.
Cleansing action of soaps and detergents. Have you ever tried mixing oil and water? Oil and water are immiscible liquids. If oil and water are mixed together, oil separates and forms a layer of its own. Oil floats on water as it is less dense than water. Why don't oil and water mix? Water molecules are bipolar molecules. They form strong electrostatic bonds with each other. Oil molecules, on the other hand, are non-polar and do not make bonds with the polar water molecules. The bonds that hold oil molecules together are weak van der Waals forces. Observe that oil molecules are large as compared to water molecules. For the mixing of any two liquids, their molecules must have similar natures. Since their molecules are not similar, water and oil do not mix. Molecules that carry charge are attracted to water and are called hydrophilic or water-loving, while molecules without charge lack affinity for water. They are known as hydrophobic. Oil is a hydrophobic liquid. If a mixture of oil and water is agitated vigorously for a sufficient period of time, an emulsion is obtained. The emulsion consists of minute droplets of oil dispersed in water. What happens if this emulsion is allowed to settle down? The oil droplets slowly coalesce and form a separate layer as before. We can infer that the oil and water emulsion is not a stable system. Let's add some soap or detergent to the mixture and see the magic. Addition of a little soap or detergent before agitating the mixture helps in the formation of a stable emulsion. The soap or detergent acts as a surfactant or emulsifier. The surfactant molecules surround the oil droplets and prevent them from coalescing. The cleansing action of soaps and detergents is due to their power to emulsify oil and dirt. Come, let's learn about the cleansing action of soaps and detergents in this module. At the end of this module, you will be able to describe the cleansing action of soaps and detergents. Soaps and detergents are surfactants which help to dislodge dirt and grease by emulsifying them and thus help clean articles. Let's take a look at the molecular structures of soaps and detergents. Observe that they have similar structures. Each molecule is composed of a long, non-polar hydrocarbon chain which is hydrophobic in nature and a short polar head which is hydrophilic in nature. The hydrophilic end is attracted by water molecules, whereas the hydrophobic end of the molecule is repelled by water but is attracted by non-polar substances like oil. The cleaning action of detergents and soaps is attributed to this special feature. Have you ever wondered how soaps and detergents work to get rid of dirt and grime? Here's how. Dirt or grime generally has an oily component. Water cannot dissolve oil, and hence water by itself cannot take away dirt. This is where soap or detergent comes of use. Dirty clothes are soaked in water containing soap or detergent. When detergent or soap molecules come in contact with the oil or dirt on the fabric, the non-polar portion of such molecules attaches itself to that bit of grime or oil. Over time, more and more detergent molecules gather around it and a micelle is formed with the oil or dirt inside it. A micelle is a ball-shaped collection of detergent or soap molecules with the hydrocarbon ends clumped together on the inside and the polar heads on the outside. Eventually, through either agitation or stirring of water or rubbing, these micelles are lifted off from the fabric surface and get into the wash water. Remember that because of the charge on the heads of the detergent molecules, the outer surface of the micelle is charged. Since these micelles all have similar charges, they repel each other and remain suspended in the water. These get removed when the water is drained off. Repeated rinsing and wringing remove all such micelles and make laundry crispy clean.
Next, there is an activity to show the action of soap in soft and hard water.
Let's study the cleansing capacity of soap through an activity. For this, we have taken soap solution, soft water in one test tube and hard water in another test tube. Add a few drops of soap solution in each test tube. Shake both the test tubes vigorously for some time and observe. You observe formation of foam in the first test tube and scum in the second test tube. From this activity, we can conclude that soap has a higher cleansing capacity with soft water than hard water.
So we have seen now soap will form lather or foam with the soft water readily, and hard water it not form the lather readily. So let us recall what is soft water and what is hard water. Water which forms lather means the foam with soap easily and readily is called soft water. What is hard water? Water that contains salts of calcium and magnesium, principally as bicarbonates. Bicarbonates are also called hydrogen carbonates, chlorides and sulfates is called hard water. Hard water does not produce lather readily with soap. So what is soft water and hard water? Water which forms lather readily with the soap, readily and easily with the soap is called soft water. Hard water which does not produce lather readily with the soap is called hard water. What is the reason for hardness of water? Because of some soluble salts like calcium and magnesium, bicarbonates, chlorides and sulfates. That means calcium bicarbonate, magnesium bicarbonate, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate. These are the salts which causes hardness in water. Now let us see, why does soap not form lather easily in hard water? We know that soaps are the sodium or potassium salts of carboxylic acids. Its molecular formula is R-COONa or R-COOK. What is R here? It is a long chain. R is the long chain alkyl group. And we have seen that in hard water there is calcium and magnesium salts are present. There are calcium bicarbonate or magnesium bicarbonate or calcium sulfate, magnesium sulfate or calcium chloride and magnesium chloride. Any of these salts will be present in hard water. So which are the ions present? Calcium or magnesium ions. Along with the anions, bicarbonate, sulfates or chlorides. So you can see here in soap molecule, sodium ions are present, and in hard water, calcium or magnesium ions are present. So what happens when soap is added to water? When soap is added to water, this calcium or magnesium, it interchange with the sodium or potassium present in the soap molecule. That means in the sodium place what will occupy? Either calcium or magnesium. So we'll get, instead of sodium salt of carboxylic acid, we'll get magnesium salt of carboxylic acid or calcium salt of carboxylic acids. These calcium salt of carboxylic acid or magnesium salt of carboxylic acid, they are insoluble in water. So they form a precipitate. These insoluble precipitates are called scum. So you can see here, if you are taken soft water in one beaker and hard water in one beaker, we are mixing both with soap, equal amount of soap, and we are mixing, stirring it equal time. So what happens? We can see here with soft water, the soap will form the lather, and with hard water, it is not forming lather. But what happens? Here the scum formation takes place. Insoluble precipitate is formed here. So how the insoluble precipitate formed, did you understand now? Because soap molecule is sodium or potassium salt of long chain carboxylic acid, RCOONA. So what is happening when it is mixing with soap, hard water? In hard water, there are calcium or magnesium ions, Ca2 plus or Mg2 plus ions. So when it is mixing with soap, the sodium or potassium ion is replaced by calcium or magnesium ion. We get calcium or magnesium salt of the carboxylic acid. They are insoluble. So they form the precipitate that is called the scum. So soap begins to give lather only after all the Mg2 plus and Ca2 plus ions present in the hard water are precipitated. So that's the reason it is not readily giving the lather. Once all the magnesium and calcium ions present in the hard water get precipitated, after that only soap begins to give lather in the case of hard water. So a large amount of soap is required here to give the lather. So how this problem can be overcome? This problem is overcome by using another class of compounds called detergents as cleansing agents. So let us see, why do detergents clean better than soap even in hard water, or what is the advantage of detergents over soap? So we have seen soaps are the sodium or potassium salt of long chain carboxylic acid. Detergents are sodium salt of sulfonic acid or ammonium salts with chlorides or bromide ions, etc. So both these molecules having long hydrocarbon chain. These are some examples for detergent molecule. The structure is not required to learn. You have to remember what is chemically detergent. So these also, like soap, these molecules are having ionic part and non-ionic part, you can see. But here what is the difference means, the charged ends of these compounds, detergent molecules, do not form insoluble precipitates with the calcium and magnesium ions in hard water. You have seen already in soap molecule, this charged end of the soap molecule that will form insoluble precipitate with calcium and magnesium. The sodium, when it is replaced by calcium or magnesium, will get the insoluble precipitate. Like insoluble precipitates are not formed in the case of detergent. So they will clean better in hard water also. They remain effective in hard water. Let us see the uses of detergents. Detergents are usually used to make shampoos and products for cleaning clothes. What are the differences between soaps and detergents? Soaps are sodium salt of long chain fatty acid, but detergents are sodium and potassium salts of sulfonic acids of hydrocarbons. Soaps cannot be used in hard water. Detergents work well with hard and soft water. Why soaps are not used in hard water? Because of the formation of scum. How the scum is formed? Because when soap is mixing with water, it will form insoluble precipitates. That is called the scum. So once all the magnesium and calcium ion get precipitated, only soap will form the lather with the hard water. But in detergents, there is no formation of insoluble precipitate. That's the reason it can clean well in hard water also. So this is one of the advantage of detergent over the soap. Now, soaps are biodegradable, but detergents are non-biodegradable. This is a disadvantage of detergent over the soap, as they are. So, actually, detergents are more advantageous than soap in all other matter. Only in the case of biodegradable and non-biodegradable, when we consider detergents is it's a disadvantage. It is they are non-biodegradable. That means it causes soil pollution or water pollution. So we have seen now soaps and detergents, the cleansing action of the soap and detergents, and what are the advantages of detergents over soap, and what is the difference between soaps and detergents. Hope you understood today's class. Thank you, children.